All right, so we did this first one yesterday, and after thinking about it a little bit, one of the things I came up with is when we were drawing these waves, one of the things that can help you out with this is to kind of figure out 5 points on the graph or the illustration to be able to figure out where we need to go. So the first one would be our start point, and the second one would be our end point. Those should be pretty easy. Our start point is always going to be at 0, and our end point is going to have to do with what the wavelength is. And so if the wavelength is 6, then that tells us where we should start and stop. So I need to think of having a point here, a point here. When we get those done, the next point needs to be kind of a midpoint. And that's going to help us get an idea. Actually, I was on the 5, aren't I? It's too far away. I can't see. So put that on the 6. Figure out what the midpoint is, because halfway between 0 and 6 is going to be 3. And the reason I'm putting the midpoint is because this is the point on the wave where it should go from the top to the bottom. And once I've got the midpoint, which in this case is 3, then that's going to be able to help me figure out where do I need to put my crest and where do I need to put my trough, because the crest is going to be halfway between these first 2 points. So my crest is going to be my 4th point that I need to find. So it's going to be halfway between the 1 and the 3, which is about 1.5. But I need to go up to the crest, which is going to be going up by 3. So my crest should be at about this point. And then the 5th point to find is my trough. The trough is going to be halfway between the midpoint and the end, but it's going to be on the downside. And I'm going to go down 3 again because that's what my amplitude is. Once I've got all of these points done, then that should make it where I can use my graphing tool. I can come up here and use my curve and go click and click and click and double click, producing the curve that we need to have. So in a lot of the examples I've seen today with people doing these, one of the issues is that I think some people don't know exactly what a wave is supposed to look like. First of all, a wave needs to be a complete cycle. And so if I've drawn it this way, this is a complete cycle, because when we go from this area to this area, I've gone up, I've gone down, and then I've gone back up. So I've made one complete loop or one complete path on this little area right here, so that if I continued this on, I would be starting a second wave as we went through. Okay, so this was should be kind of how the first one is done. We went over this one yesterday. The second one's asking us to draw a couple of different things. So the first one, again, wants us to make a wavelength, but in this case, the wavelength is 3. So that I'm going to go ahead and real quickly, I'm going to start at a 0, and I'm going to end up at 3. Halfway between that is about 1.5. And then if I find my crest, I need to go up 2. So the amplitude is going to be at this height, and it's going to be halfway between the beginning and the midpoint. So that's going to put it about right here. I want to do the same thing with the trough. The trough is going to go down 2. It's going to be halfway between these points, and would end up going about right here. So if I connect these, I should get a graph that looks like this, or a wave that looks like that. And then what I'm asking you to do is to draw a second wave that has twice the amplitude, but has the same wavelength to it. So it's going to start and end at the same place. So all my points are approximately the same. The only difference is now my 2 is going to go up to a 4. And my 2 down here at the bottom is going to go down to a 4. So if I draw a second wave, I'm going to start here. Instead of just going up to 2, I'm going to go up to 4. Instead of going down to 2, I'm going to go down to 4, and then I'm going to finish it back up in the same place. And you can make these different colors, but both of these should be what our final result is on the second one. Third one, similar to the second one, I'm asking you to draw a couple things. Again, a transverse wave like we've been drawing, amplitude and wavelength of 2 and 3. So that one actually should be exactly like the ones we've been doing. So an amplitude of 2 with a wavelength of 3. We're going to start at 0, end at 3. Our midpoint is going to be halfway between those two. An amplitude of 2 is going to put our crest halfway between these 2 points at 2. And then our trough should be down here. This is going to look exactly like the first one on the second slide. All right, and then it says draw a second wave that has twice the wavelength, but the same amplitude. So if our first wavelength was 3, then our next one is going to be 6. So it's going to look exactly the same in terms of its height, but it's going to be a lot longer. So if I, again, pick out my points, I'm going to start at 0, but we're going to end at 6, just like we did on the first slide. That's going to put 3 at my midpoint, and then that's going to put my top point here and my bottom point here. So if I come through and connect these again with my little tool up there, it's going to put here, basically here, here. And so that is what the end of our third slide should look like. So I got 2 waves, identical amplitudes, but the second one's got a little bit longer wavelength to it. So if I clear off my dots, it would end up looking kind of like this. Okay, this fourth slide requires a little bit of thinking because I again ask you to draw the same wave that I've been asking you to draw with an amplitude of 2 and a wavelength of 3. So let's go ahead and get that taken care of. It shouldn't be hard at this point because we keep drawing the same one. So if our wavelength is 3, let me use the mouse. So it's going to go here. Something along those lines. So this one's a little bit more complicated because it asks us to do something about the frequency. And this is where I'm going to have to do a little bit of real quick teaching because frequency can't necessarily be graphed on here. We have to infer frequency by the wavelength. This is what I went over in class. I mentioned if you were at the beach and were listening to waves, you might be able to hear the frequency. Well, let's think about being on the sidewalk and these dots representing cars that were coming by. So if you're on the sidewalk and cars were coming by and this was the frequency, you might get in your head how far apart those cars were. If we increase the frequency that you started noticing the cars, assuming they were still going the same speed, then in your head you should have to figure out that those cars would start getting closer and closer together. And so what the relationship here is that if the frequency goes up, then what would have to happen to the wavelength, or in other words, the distance between these things, the wavelength would have to go down. So there's a perfect relationship between these two things. If the frequency is doubled, then the wavelength is flipping that fraction over. It's 1/2. You know, if we had 4 times the frequency, our wavelength would become 1/4 of what the original one actually was. Okay, so with this one it says we want to have twice the frequency. So again, twice the frequency, that means half the wavelength. So instead of going from 0 to 3, we're going to scrunch this one up pretty good, and it would actually end here at 1.5. So we're going to have a really, really short wave, because the shorter the wave would be, the higher the frequency would be. Also, see if I can squeeze all this in here. So it should go up and then kind of back down, and would just look something like that. So these 2 waves, again, if you could color code them, that would be great. And the other thing I'm not showing you right now that y'all should be able to do with no problem is to go through and label these in the right ways with the crest and trough and everything. That's just basic vocabulary. So the longer wave was the first one. The shorter wave would be the second one. And hopefully you're making your waves look like this. I've had a lot of really kind of funky waves that people have been making today with their drawing tools. This 5th one, I was asking you to go back and look at your notes because I wanted you to compare an X-ray and a microwave. If you go back and looked at your notes, there was a page where there was a potato getting a suntan, you know, because that's what potatoes do. I guess he was baking. And if you looked at those pictures, what we saw is that the difference between an X-ray and a microwave and all the other rays that we have was simply in their wavelength. And so at one end of what we would call the spectrum, at one end of our spectrum, we have really short waves, so they're not very long at all. And at the other end of our spectrum, we have really long waves. this wavelength, a lot of times we can think of as it has a lot to do with the energy of the waves as well. So the more energetic the wave is, the closer they're going to be. That has to do with their frequency, because if the waves are really, really close together, they're going to have a high frequency, which is a lot of energy. Whereas if they're really far apart, they're going to have a lower frequency, and that's going to be a lot less energy. So you may think that a microwave has a lot of energy, but relatively speaking, it doesn't. An X-ray has way more energy because it can go through all of our body except for our bones. If you went back and looked at that slide that I had with all this, what we would find is that X-rays are way shorter. So this is more like the X-ray, and this is more like the microwave. And I'm not asking you to draw a specific length of wave here. All that I'm asking you to do is to draw a relative. That means we're just kind of comparing them to one another. So if I drew a couple of these, go up here and grab my little drawing tool. So I might draw a microwave that would be, let's give it an amplitude of 3, 3, 6. So that might be my microwave. And if I wanted to compare that to an X-ray, the X-ray should be a lot shorter. So I could just maybe make its wavelength be like 3 or something. And I don't think this is going to be perfect, but you'd kind of get the idea there. So if we compared these waves, we got one wave that's going to be really long. And again, if you wanted to continue making this a little bit further, that's what happens when you stop and start again. And so we could label the longer wave the microwave, because microwaves are longer. We could label the shorter wave an X-ray. And again, we could come up with all kinds of different possible combinations of how long these things need to be. It's just a matter of an exercise of comparing lengths and knowing which ones would be longer and which ones would be shorter. And finally is this last one, which is, it says, impress me, draw a longitudinal wave with a wavelength of 3 units. Now, longitudinal waves are really, really hard to do. I can't draw them very well by hand. I surely can't draw them very well on the computer. But remember, longitudinal waves are the ones where we have squished together parts and we have parts that are spread further apart. That's where our compression and rarefaction terms come from. So if I were drawing one of these, and you know, if the wavelength is 3, then maybe I've got a compression at 1 and a compression at 4, because those are 3 units apart. So we'll see how ugly I can make this. So you might just do something like this, where like at 1, they're kind of really close together, and then they get a little further apart. And then by the time we get back to 4, they start getting really close together again. And then they get a little further apart. Oh, that was bad. And then by the time they get to 7, which is 3 more units from 4, they would get close together again. And let's end that, because that's getting awful. And so we could label this, because the compression again would be the part where you've got the stuff close together, and then the rarefaction would be the part where they're going to be a little bit further spread out from one another. I don't expect that one to be very pretty. I can't expect y'all to make them any prettier than I do, so that's probably the best it can be on that one. So there you go. I have done your work for you. Congratulations.